So continuing on, okay, the only thing that makes this different than previous examples, first of all, it's a cosine, and the last example we did was a sine. That's not a big deal. But we have this -2 tagged on at the end. So here's how I would do it, okay? If I can produce the graph of this, I can just shift it down by 2. So normally, my amplitude is the number, absolute value of the number multiplying sine or cosine. So that would just be 4. Okay, so normally what I would do is I'd say I'm trapped between y equals 4 and I'm trapped between y equals -4. But I know I'm eventually going to have a downward shift by 2. So instead of being trapped up by 4, I shift that down by 2 and I get 2. And instead of having a lower bound of -4, I shift that down by 2 and I get -6. So now instead of being trapped having a range from plus or minus 4, it's between -6 and 2, and that's just because that original range has been pulled down. Okay. So then what I would do is I'd look at what's the period. It is 2 pi over the number multiplying x, which is pi, so that's just 2. Then I'm interested in what's a quarter period. Well, a quarter of 2 is a half. So I come over here, and starting from x equals 0, sorry, let me erase that because it's not going to be in the middle. Where did? Oh, I'll just erase the whole thing. Sorry. So our amplitude is 4. Our period is 2. Therefore, our quarter period is 2. Okay. We know that we are shifting down by 2. So my biggest value is going to be y equals 4, but then down by 2, so 2. My lowest value is going to be y equals -4, but shifted down by 2 becomes -6. Okay. What does a negative cosine normally look like? It normally starts at its minimum and does this shape. Okay. So that is a negative cosine curve because I have a negative number times cosine. The only issue now is what's the period? The period is 2. So I would start this at x equals 0, and I would end it at x equals 2. And then you can label quarter period points as you go. Okay, so this is 0, and it's at the minimum value, which is -6. Okay, because remember, we did shift down by 2. This point here is now a quarter period further, so that's 1/2, and it's going to be at the middle value. Well, what's the middle value between the lowest, and +2, the highest? You can take the midpoint, and you'll get -2. Alternately, in my cosine curve, if I get out a 0, overall I now have -2. Then I march forward another quarter period. So from 1/2, if I go forward by 1/2, I'm at x equals 1. I'm now at the biggest value this function ever sees, and we've already determined that's just y equals 2. I march forward by a quarter, I'm at 3/2, and I'm back at the middle, which we already know is -2. And then at the end, I've gone a full period to 2, back to the minimum, which is 6. Okay, so this is typically how you'll do them when you're drawing it by hand. It's not a very uncommon sort of problem. Draw one full period of the following sinusoidal function. Okay, so let's do another one. Oops, let me clear this off and we can see how they do it. So they begin by graphing -4 cosine pi x. So we get an amplitude of 4 and a period of 2. Okay. So they divide it into quarter periods. Find what those quarter periods are. Okay, there we go. Notice what they're doing is they're first graphing just -4 cosine of pi x. They haven't done the -2 at the end yet. So there is -4 cosine of pi x here, and then they just shift it down by 2. And they get exactly the same reference points that we had on the previous slide. Okay. The domain is all real numbers. Sinusoidal functions always have a domain of all real numbers, but the range did shift. Okay, the amplitude of 4 makes you think -4 to 4, but then the vertical shift of 2 down says instead of -4 to 4, it's -6 to +2. So there's the range. Okay, let me let's do another one because this is a handy thing to practice. Graph one period of y equals -3 sine -8x. Okay, so first things first, I don't want a negative sign on the inside of my argument. So I bring that negative sign out because the sine function is odd. So this would just become positive 3 times the sine of 8x. So without using a calculator at all I do is the following. I say the amplitude is, oh, and I should have put a vertical shift on here. Let's do, for example, plus 10. Okay. So the amplitude is just the absolute value of 3, which is 3. So if I'm going to draw one complete period inside this box, okay, normally the top would now be 3 and the bottom would be minus 3, but I have a vertical shift of 10. So it's actually bottomed out at 7 and its maximum value is 13. Okay. The period is 2 pi over the number multiplying x, which is 8. That's pi over 4. Okay. Now what shape do I draw? I have a sine with a positive number in front of it. At the beginning, it looks like it's negative, but by the time I use my even odd properties, this has become positive. And the positive sine shape is exactly this. One period of it looks like that. Okay. Remember, positive sine, positive cosine, negative cosine, basic shapes that I put up on an earlier slide. And now the only thing that remains is to label key points. So this started at 0, and its median value, the value in the middle, would normally be 0, but it's been shifted up by 10. Then I go forward a quarter period. Well, if the period is pi over 4, a quarter period is pi over 16. So this point here would be pi over 16, and then I'm at the maximum, which was 13. Here I'm back down at my median, so my height is going to be 10. If I go another pi over 16 forward from pi over 16, I'm at pi over 8. Here I am at 3 pi over 16. I've done 3 movements of a quarter period. And I'm at my minimum, which is at 7. And here at the end, I've done a full period. That's pi over 4. And back at my median height, which was 10. So this right here would be a nice typical full credit solution, as long as you have some work backing it up. Don't just draw the picture, because then I assume all you did was copy it from a calculator. But really, we don't need to see very much work. Here, this shows you that this is at a height of 3, and now I see how you've accomplished the, let me switch to different color so that we can see what I'm pointing out a little bit better. So in terms of justifying work, this here tells me you see the amplitude is 3. This work tells me you know you've done a vertical shift by 10. You've computed the period and the quarter period, and then I can trust that all of these labels are accurate. Okay, so we don't need to see a lot of work, but if all there is a picture, we assume you copied it off your calculator. What's even worse, by the way, and this always happens, 2 or 3 people will draw this. So the question might say, draw, one period of y equals negative 4 cosine of 10x minus 6. Here's something I see someone do. Like, literally, that's it. That is all they put down on their page. And I can tell what they did is they punched it into their calculator. Their viewing window was like all wrong. So their viewing window probably showed this. So they were seeing many, many periods. You were only asked to draw one period. And the problem will usually also say label key points. Key points just means every quarter period. And they didn't label any points. This is clearly someone who just poked it into their calculator, had no idea what they were looking at, shrugged and say, well, maybe if I draw this down, I'll get credit because I graph. Yeah, but you had no idea what you're doing. That is a 0 credit answer. Anyway, moving on. We're going to reverse this a little bit. Now, instead of having a function and trying to find the picture, you're given the graph of a sinusoidal function. Can you find what function this is? So it does have a characteristics of a sine or a cosine, and specifically, because it is starting at the 0 and then going up, it has the characteristics of a sine function with a positive number in front of it. So remember, starting at 0, this is a positive sine. This is a negative. Starting at 0, this is a positive cosine. And this is a negative cosine. Okay. So this looks like a positive sine function, and we see that the maximum is at 2, which occurs at a value of x equals 1. Okay. We also see the period is 4. So what we know is, since the maximum and minimum are negative 2, I want to put either 2 or -2 out there, but since we want a positive sine curve, I want a positive number there. We also know the period is 4, but the period is 2 pi over omega. So if I solve 2 pi over omega for 4, equals 4, so we have 2 pi over omega equals 4. I multiply by omega, I get 2 pi equals 4 omega. Divide by 4, pi over 2 equals omega. So we have found this needs to be 2 and this needs to be pi over 2, and there is your function that gives you that graph. This is a more common type of exam problem, by the way, because it's not possible for you to just punch this into a calculator and put stuff down without knowing what you're doing. You can't just copy the picture. In other words, you're given the picture. You have to figure out what the formula was. So let's do this again. First of all, what shape is it? It starts at 0 and goes down. So this is a negative sine. Its period is 8. I also need to determine what its amplitude is. And assuming the picture is supposed to be kind of accurate, it appears to be going between 3 and -3. So I'm going to say this is a sine function. Its amplitude is 3, but it's a negative sine function. And the only thing left is to determine what goes in there. But 2 pi over omega is the period. This appears to have a period of 8. So I multiply by omega, and I get 2 pi equals 8 omega. Divide by 8, omega equals pi over 4. And there it is. So there is a function that matches this picture. And again, if all you did was write this, you'd get no credit. It doesn't take a lot of work, however, to convince us you know what you're doing. There we go. That's really all we need to see that you knew how to compute this. But if all you do is write down the answer at the end, even if you manage to do it in your head, okay, it's totally possible once you practice this enough to do the relevant computations in your head, but actually show you got there. Don't just put the answer down. Too many of you are just going to be cheating anyway. Don't be one of them. So here's the work behind it. They found the amplitude is 3 and omega is pi over 4. It's decreasing near the origin, so it's been reflected, so it's a negative sine curve, so they use a equals -3, and there it is. Okay, so that's it for this section. Given a sinusoidal function, can you graph it? And given the graph of a sinusoidal function, can you determine what function it was? And that's basically the 2 types of problems you want to be competent at doing at the end of this section.